Hey guys, welcome to another video from Foolish Engineer. Last time we saw how we can design a voltage regulator using discrete components like BJT and Zener diodes. This time we'll see the design of a constant current regulator with simple circuits. So let's go for a ride. The very first thing we need to ask is, what is a constant current regulator? Well, any source which provides constant current irrespective of any change in output load or input voltage is known as constant current regulator. Let's see the basics of current and voltage. When we connect a normal voltage source, let's say a battery, to a resistor, then the current flowing through a resistor will be the division between voltage applied to it and its resistance. Well, this is nothing but the basic Ohm's law, right? So, with this logic, the constant current regulator changes its own resistance in order to give the constant output current, which may result in changing output voltage to pump the current in the load. So, when the load current is supposed to be increased, the regulator decreases its resistance, and when the load current is supposed to be decreased, the regulator increases its resistance. Well, keeping that in mind, let's see a circuit which can provide constant current to a load. Let's consider we need to power an LED. For that, it needs to be given constant current of 50 milliamperes. So, we can design a current regulator which will provide 50 milliampere constant current irrespective of its changing input voltage or even if we change the LED. The very basic circuit that we can design is using LM317. Well, LM317 is a variable voltage regulator. The output voltage of this regulator can be adjusted by a resistor, which is supposed to be connected at the adjustable pin of the IC. So, how can a voltage regulator be used as a current regulator? This regulator is designed such that the voltage between its output pin and adjustable pin is regulated at 1.25 volts. In voltage regulator application, we need to use a voltage divider using some resistors. But for current regulator, things get super easy. We just need to add a resistor in series between the output and adjustable pin. So the LM317 tries to maintain 1.25 volts drop across this resistor. And to do that, it needs to source constant current to the output branch. Let's take an example. We need to provide 50 milliamperes at the output. The input voltage is 8 volts and the forward voltage drop across LED is 2.2 volts. Now we will select this resistor. The value of this resistor can be calculated with this formula. So the value of this resistor will be 25 ohms. Now the power dissipation of the components used in the circuit can be calculated as voltage drop across the component and current flowing through it. So the power dissipation across the resistor will be around 62.5 milliwatts. The power dissipation across LED will be around 110 milliwatts. And the power dissipation across LM317 will be around 227 milliwatts. So, if we change the input voltage, the power dissipation across this regulator will change, which will keep the power dissipation across LED and resistor constant, because the current flowing through both of them and voltage drop across both of them is constant. And for stability, we can add some filter capacitors to this design as well. Well, that's how the circuit is able to provide a constant current of 50 milliamperes. Let's take the simulation of the circuit. I've connected one LED at the output. At the input side, I'm giving 8 volts DC supply. Now, when we simulate this, we get the constant current output of 50 milliamperes. If we change the input voltage from 8 volts to 10 volts, still the output current is 50 milliamperes. And now, if we add one more LED, that means if we change the load, still the output current remains same. Well, there are many advantages of this circuit. We need very less components to get constant current out of this voltage regulator. There is an over temperature protection in such ICs, so it could come handy when more load current is required and it tries to increase the junction temperature of the IC. The voltage regulators have a wide input voltage range, so we can use them very easily. But there are some limitations also. For small current applications, this regulator might be very bulky. Due to quiescent current from regulator, there will be some power losses. Well, that was just one way of designing a current regulator. In the next video, we'll see how we can design a constant current regulator using discrete components like transistor and Zener diode. I hope you got something from this. If you haven't, you can watch the video again. Still, if you don't, you can ask your doubts in the comment box below. Hit the like button if you like this video, subscribe to my channel, and finally, thanks for watching.